NEET Cracker, channel of comprehensive concepts in physics, chemistry, and biology. Welcome to NEET Cracker, the ultimate channel for NEET exam preparation in physics, chemistry, and biology. Our channel is dedicated to providing you with mind maps and concise explanations of all the important concepts covered in the NCERT curriculum. We go beyond the core concepts, delving into the periphery of each topic to ensure you grasp the subject thoroughly. With our detailed videos in English, you'll be equipped with the necessary knowledge to crack the NEET exam with flying colors. 5 keywords: NEET exam preparation, physics concepts, chemistry concepts, biology concepts, NCERT curriculum. In this video, we will guide you through the essential concepts of physics, chemistry, and biology. Our aim is to enhance your understanding and provide the necessary foundation to excel in the NEET exam. We focus on the NCERT curriculum and go beyond to explore the depths of each subject. So, let's dive in and embark on this exciting learning journey together.
Hello guys, welcome back to my channel NEET Cracker. Today we will be learning about circular motion. So let's start without wasting any time. First, we will learn about angular velocity. Angular velocity or instantaneous velocity. If a particle covers a small angle d theta in a small time interval dt, then its angular velocity is defined as omega is equal to d theta upon dt. Parallel to average angular velocity, we can write average angular velocity as V average is equal to delta theta upon delta t. Angular acceleration. If the angular velocity of a particle changes by dw or d omega in a small time interval dt, then the angular acceleration is defined as alpha is equal to d omega by dt. Also, alpha is equal to omega dot d omega by d theta. Analogy between linear kinematics and circular kinematics. Linear kinematics differential equation V is equal to ds by dt, A is equal to dv by dt, and A is equal to v dv by ds. Circular kinematics differential equation omega is equal to d theta by dt, alpha is equal to d omega by dt, alpha is equal to omega dot d omega by dt. Linear kinematic solution. S is equal to ut plus half at square, V is equal to u plus at, v square minus u square is equal to 2as, and r is equal to r naught plus ut plus half at square. This formula will be useful in gravity problems or throwing an object down or upwards from a cliff or a building. Circular angular kinematics solution. Delta theta is equal to omega naught t plus half of alpha t square. Omega final is equal to omega naught plus alpha t. Omega final square minus omega naught square is equal to 2 alpha delta theta, and theta final is equal to theta naught plus omega naught plus half of alpha t square. Now let's learn about relation between speed and angular speed. Here from this figure we can see v is equal to dl by dt, omega is equal to d theta by dt, dl is equal to r dot d theta, and v is equal to r dot d theta upon dt. We get this equation by multiplying this equation by 1 upon dt. So the final formula we get is v is equal to r into omega. Uniform circular motion. When a particle moves along a circle with constant speed, we call it uniform circular motion. Centripetal acceleration. Magnitude of delta V vector is equal to V dot d theta. Magnitude of dv vector is equal to V dot d theta. AC, or the centripetal acceleration, is equal to magnitude of dv vector upon dt is equal to V dot d theta by dt. Centripetal acceleration is equal to V omega is equal to V square by r is equal to omega square r. Now a question for all of you. The seconds hand of a clock is 1 upon 2 meters long. Find A, its angular velocity. Therefore, omega is equal to 2 pi by 60 is equal to pi by 30 radian per second. This is the angular velocity. Then the speed of the tip. V is equal to r into omega is equal to 1 by 2 into pi by 30 is equal to pi by 60 meter per second. This is the speed of the tip of the seconds hand. Then angular acceleration of the tip. Alpha is equal to 0 because it is uniform circular motion. AC, or centripetal acceleration, is equal to V into omega is equal to pi by 60 into pi by 30 is equal to pi square upon 1800 meters per second square. Non-uniform circular motion. From these two figures, A is equal to dv vector by dt. Component of acceleration along center is AC. AC is equal to d of Vc upon dt is equal to V d theta upon dt. Centripetal acceleration is equal to V into omega is equal to V square by r is equal to omega square r. Component of acceleration along tangent, so we get tangential acceleration. At is equal to dvt upon dt, or tangential acceleration is equal to derivative of tangential velocity upon with respect to time is equal to dv by dt is equal to d into r omega upon dt is equal to r alpha. Therefore, the final or the net acceleration is equal to centripetal acceleration vector plus tangential acceleration vector. The net acceleration vector is equal to V into d theta by dt c cap plus dv by dt t cap. Here c cap represents the direction of the acceleration, which is towards the center of the circle, and t cap represents the direction of the tangential acceleration, which acts along the tangent of the circle. Note, magnitude of total acceleration is given by under root of at square plus ac square. C cap is equal to minus cos theta I cap minus sin theta j cap. T cap is equal to minus sin theta I cap plus cos theta j cap. V vector is equal to V dot t cap. From the whole proof, we get dv vector by dt, or acceleration net, is equal to V into omega c cap, means the direction is towards the center of the circle, plus dv by dt t cap, means it is going through the tangent of the circle. Now let's deal with a question. A particle moves in a circle of radius r such that its speed is given by v is equal to t. Find its tangential acceleration. What is its centripetal acceleration at a general time? First, let's find out the answer for the first question. Here we have to find tangential acceleration, which is at is equal to dv by dt is equal to dt by dt is equal to 1. Second question, we have to find the centripetal acceleration is equal to v square by r is equal to t square by r. The third question is, after how much time does the total acceleration make an angle of 60 degree with the tangential acceleration? From this figure, we can see the net acceleration makes an angle 60 degree with the tangential acceleration. Therefore, tan 60 degree is equal to AC by AT. From here, under root 3 is equal to T square by R into 1. Therefore, T is equal to whole under root of R under root 3 seconds. Now let's move on to the next question. The speed of a particle moving along a circle of radius r is given by v is equal to under root of t. Then first we have to find the angle covered by a particle at general time. The second question is to find the angular acceleration of the particle. The third question, the time at which the tangential acceleration and the centripetal acceleration are equal. Now let's go find the solution of the first question. That is the angle covered by a particle at a general time. Therefore, r into omega is equal to v is equal to under root of t. Therefore, d theta by dt is equal to under root of t upon r. Now, by shifting this dt through to right hand side, we can integrate on both the sides. Now, integrating d theta from 0 to theta on the left hand side, and by integrating under root t by r on the right hand side from 0 to t, we get theta is equal to 2 by 3 rt into under root of t. Now, the second question is to find the angular acceleration of the particle. Here, alpha is equal to d omega by dt is equal to derivative of d theta by dt with respect to time. Alpha is equal to derivative of under root of t by r with respect to time is equal to derivative of t power 1 by 2 upon r with respect to time. Alpha is equal to 1 by 2r under root of t. Here we found out the angular acceleration is equal to 1 by 2r into under root of t. Now the third question is the time at which tangential acceleration and the centripetal acceleration are equal. As we know, the centripetal acceleration is equal to v square by r, so we get it as t upon r, as v is equal to under root of t. Tangential acceleration is equal to r into alpha is equal to 1 by 2 into under root of t. Therefore, t upon r is equal to 1 upon 2 under root of 3. 2 under root of t gives t power 3 by 2 is equal to r by 2. Therefore, t is equal to r by 2 power 2 by 3. Now, let's look upon to the general plane motion as a series of infinitesimal circular arcs. Any motion along a general curve in a plane can be thought as a series of infinitesimal arcs with center of curvature and radius of curvature defined locally as follows. Local center of curvature. Draw the perpendiculars to the curve from the neighboring points. The point of intersection of these perpendiculars is called the local center of curvature at those neighboring points. Local radius of curvature. Distance between neighboring points to the center of curvature is called the local radius of curvature. From this figure, we get to know that this is the local center of curvature and this is the radius of curvature. Now, there is a note point for all of you. Since the small segment of a general curve is that like a circular arc, we can apply the concept of circular motion to a general curve as well, where tangential acceleration is equal to dv by dt is equal to r into alpha. Centripetal acceleration is equal to v square by r is equal to omega square into r is equal to v into omega. R is equal to v square upon centripetal acceleration, and the net acceleration is equal to under root of centripetal acceleration square plus tangential acceleration square. Now there is a question for all of you. Find the radius of curvature of a projectile launched with speed u at an angle theta. It is flying at an angle phi with the horizontal. Where is the radius of curvature maximum? Where it is minimum? So, from the given figure, the projectile is thrown at an angle theta with a speed u and it is at an angle phi at a speed v. So, r means radius of curvature is equal to v square upon centripetal acceleration. So, we get v is equal to u cos theta upon cos phi because the horizontal component of velocity is equal at any point in a given projectile. Therefore, v square upon centripetal acceleration is equal to u square cos square theta upon cos square into phi dot 1 upon g of cos phi. Here centripetal acceleration is equal to g cos phi. Therefore, radius of curvature is equal to u square cos square theta upon g into cos cube phi. For radius of curvature to be minimum, cos phi is equal to 1 or phi is equal to 0 degree means at the highest point. For radius of curvature to be maximum, cos phi should be minimum or phi should be maximum means phi is equal to theta. Therefore, r max or radius of curvature max is equal to u square upon g cos theta. Now we will learn about motion in a vertical circle. The bob of a pendulum hanging from a string of length r is given as a horizontal speed u. Find first the tension in the string as a function of angle theta transversed by the string. Now we look upon to the solution of the first question. This is a bob hanging. This is the radius r or the length r. This is angle theta. This is speed u. This is tension T. From this figure, we can locate a equation which is T minus mg cos theta is equal to mv square upon r, which is the equation of circular motion. From law of conservation of mechanical energy, we can draw this equation, which is minus mgr plus half of mu square is equal to half of mv square minus mgr cos theta. From equation first and equation second, we get tr plus 2mgr minus mu square minus mgr cos theta is equal to 2 into mgr cos theta. So, the tension in the string as a function of angle theta is equal to mu square plus 3mg r cos theta minus 2mg r upon r. Now let's look upon to the next question, which is what happens to the tension as theta increases. The answer is the tension decreases as theta increases until theta is equal to 180 degree. The third question is what will happen if the tension becomes zero somewhere. The answer is if the tension becomes zero, projectile motion starts, the particle deviates from the circle. The fourth question is what should be the minimum value of u to complete a circle. The solution goes as follows. Tension minimum is at theta is equal to 180 degree. Therefore, T minimum must be greater than 0 so that it completes a vertical circle. Therefore, mu square plus 3 mgr cos theta minus 2 mgr must be greater than 0. Mu square minus 3 mgr minus 2 mgr must be greater than 0 as theta is equal to 180 degree. Therefore, 5 mgr is less than mu square. Therefore, u must be greater than or equal to under root of 5gr. So, the bob will complete a full vertical circle. Now, the fifth question. What should be the value of u so that the bob completes or reaches the horizontal level? So, according to the law of conservation of mechanical energy, half of mu square is equal to mgr. Therefore, u minimum for the bob to reach the horizontal level is equal to under root of 2gr. Now let's look upon to the sixth question, which is what will happen if the value of u is between that in question 4 and question 5, means in between theta is equal to 180 degree and theta is equal to 90 degree. So according to the law of conservation of mechanical energy, half of mv square minus 0 is equal to half of m into under root of 5gr whole square minus mgr. Therefore v is equal to under root of 3gr. Now the next question, which is for the bob shown in the previous question, what should be the minimum velocity given at the bottommost point so that the string becomes slack at an angle of 37 degree above the horizontal. So t minus mg sin theta is equal to m into v square upon r, and g sin theta into r is equal to v square. So v is equal to under root of 3 by 5 gr. According to the law of conservation of mechanical energy, mg into r plus r sin 37 degree is equal to half of mu square minus half of mv square, where we found out that u is equal to under root of 19 by 5 gr. Now we move to the next question, which is a bob is released from a horizontal position so that when string becomes vertical it gets tangled in a nail as shown. Find the minimum value of k so that the bob executes a circle around the nail. So under root of 2gr must be greater than under root of 5g into r minus kr. Therefore under root of 1 minus k must be less than under root of 2 by 5. Therefore k must be greater than 3 by 5. Now let's learn about motion in a vertical circle inside a smooth hoop. The structure of this problem is identical to that of a bob tied with the string, except that here tension is replaced by the normal reaction. Hence all the results of the previous situation apply to this situation as well. Now let's move to a question. An arc of angle 2 theta is missing from a smooth vertical hoop as shown. Find the speed required at the bottom so that the cyclic motion of the block continues perpetually. According to this figure, 2r sin theta is equal to u square sin 2 theta upon g. Therefore, rg upon cos theta is equal to v square. According to the law of conservation of mechanical energy, half of mu square minus half of mv square is equal to mg into r plus r cos theta. It is useless but a valid equation, which is mg plus mg cos theta plus normal reaction is equal to mv square upon r. Vertical circle for a bob attached to a massless stick. According to the law of conservation of mechanical energy, for u minimum or initial velocity minimum, half of mu square is equal to 2 mgr, where we get u or initial velocity is equal to under root of 4gr. Question. A block rests on a top of a fixed smooth sphere of radius r. At what angle from the vertical will the block leave contact from the sphere if it is slightly disturbed? So according to this figure, we apply law of conservation of mechanical energy. Half of mv square is equal to mg into r minus of r cos theta. So normal reaction plus mg cos theta is equal to mv square by r. As we know, normal reaction is 0 as the block leaves the sphere. Therefore v square is equal to rg cos theta. Therefore half of m into rg cos theta is equal to mg into r minus r cos theta. Rg cos theta is equal to 2gr minus 2rg cos theta. cos theta is equal to 2 by 3. Therefore, we get theta is equal to cos inverse of 2 by 3. Thank you friends for watching the full video. Please share and subscribe and hit the bell icon for further notifications. Thank you.
Thank you for joining us today on Neat Cracker. We hope you found this introduction to our channel and mind maps informative and exciting. Don't forget to subscribe to our channel to stay updated with all our latest mind maps and NEET exam tips. Remember, Neat Cracker is here to guide you towards success in cracking the NEET exam. Visual display of subscription button and social media hand. Keep studying, stay motivated, and best of luck on your NEET journey. See you in the next video.